All right, hello everybody. We have a few in the studio audience tonight. Appreciate that. Always good. I mean, I suppose even if everybody had to work or on vacation and couldn't make it, I could still do it. But it's much more fun having a live group to go back and forth with. And I know that people do watch the video. So this is episode number 3, and this show is evolving. I spent about 6 hours a day. I'd say working, but it was fun. It wasn't really work. Just kind of working on the Facebook group and adding things to it and doing research and looking stuff up and reminding myself of things. And so it's a blast for me. So I appreciate you all hanging in there. All right, so overview. First, we'll do this is kind of what I'm going to try and follow. Overview of the new guides. I put on some new guides on the Facebook group. We'll talk about the Big Bang from a Bane model. I don't mean Batman's nemesis. I mean as a membrane model. This just in. All right, very good. Thank you, Anthony. We'll talk about the standard model a little bit, at least the basics of it. And we'll talk about where that came from, and we'll show a little animation, about a 6-minute. It's something I show in class every year before Dr. Strauss comes. But since he didn't come this year, I'm going to show it. And we'll have to stop recording for that, and then I'll pause and talk about some parts of it. That's about 6 minutes. Then I want to get back to good old mechanics, as really this is more of a mechanics course. I'm trying to keep it a variety show. And that'll be on tides and tidal forces, still kind of staying with that opening gravity theme. And then if we have time, we'll get to pulleys, and that'll lead us into some machine stuff. But we'll get into some simple pulleys tonight and talk about the forces involved and how you treat that as a system, internal, external. Some of these concepts we've already talked about a little bit. And at some point, Zachary Burkett is supposed to chime in. And when he does, I'll interview him. He just got his license for civil engineering with transport emphasis. I have somebody lined up for Thursday night as well. So I'll try and on every episode, I would like to do a 5-minute, and they'll just be on Zoom, so it should be easy. I gave them the Zoom address. And so we'll do that. See how that goes. It's my first time to try that. All right, so see what happens. Every night's an adventure here. This is the interview. This is who I'm going to do then a little bit. All right, so I'm going to get off this share, and I'm going to share the screen just to show you what I've been messing with today. Okay. So this is our, as you know, this is our Facebook group. Move this out the way. But I added a few wrinkles today. Of course, the best way to look at this, if you're looking at it through, you all probably know this, but if somebody's watching the recording, if you're looking at it through discussion, it's going to be a mess, because that's just like new in Reddit. I mean, it's whatever comes up chronological. I do notice we have 33 members right now. And you go, wait, 33 people are paying? No. A lot of these members are alumni or even family members of mine. In case I want to interview them, I would like them to know a little bit about what we're about. So that's why we have so many members. And if they want to show up, they can. All right, so let's go to guides. And there's 2 new guides. The first one, of course, is, all these say optional because nothing's required here. But the first guide is the one you'd go to the most. That's the screenshots, as you know. There's yesterday's. Brandon missed yesterday, so he could go here and see what happened, as you know. find. But once again, I'm not just talking to you guys, but you can find there's captions for all these. If it's important enough, there's a calendar what's coming up. We did a joke Monday, talks about a little bit of stuff we did that day. So if we go too fast on something, you can always tell me to hold up, but it will be eventually. You'll find it on the screenshots. Now, it's taken me a lot of times after this, like now it's 7:30 at night, I got to eat. We got family things going on. I got to walk the dog, those kind of things. So I don't always get everything right up like I used to in the spring. So it may take, you got to give me 24 hours to have all the screenshots up and the video up. And it's on the link to the video is here. This is what, I mean, I'm trying to keep this thing somewhat secure, but if you go to the comments, like from yesterday, you'll find there's the link to and then it'll be one of the first couple of links. There's the link to episode 2. There's the link to one of the videos we watched, and there's a link to a couple of sources. Okay. So that's there. And if somebody were to go to my Facebook group, they could just, but what I'm saying is everyone that's needing the course is paid. So I'm not worried about that. I'm not good at that money stuff anyway. I'm always telling my wife today, is I just don't want to, let's just do it as Patreon or something. But we're sticking it this way for now. The second guide is papers. I added another paper today. This is what we will get to. That's pulley systems. And then it gets into inclined planes and pulley systems. So we'll touch on that today. We'll hit it a little more on Thursday. We don't meet tomorrow. We only meet Monday, Tuesdays, and Thursdays. Okay, so Zach's giving me a heads up that he's going to be showing up here. Okay. So when Zach gets here, we're going to stop and interview and then go back to what we're doing. Okay, so there's the next one is research reference papers, and that's the 20 sheets we already have. Maybe we'll get enough tonight where I can feel like I can put another one together for next time. That'll be sort of our archive of what's happening. Hold on. Let's see it. All right. Okay. And then the next one is next one's new, and these are reference websites for physics. They're in no particular order. There's about 12 or 13 of them. And these are some of my go-to websites. Anytime. He's asking when he should come in. Hold on. Anytime will work. Okay. So this is Kathy Love's Physics and History. If you like history or science, it says it's like she started off doing stuff on electricity, and then it's kind of branched into all kinds of physics. But I support her through Patreon, and I think she's great. And you ought to watch some of her stuff. And so there's a link to hers. 3 blue, 1 brown. That's good for calculus. If you're needing calculus application, if you need any kind of math, kind of blends math and science, math, physics, chemistry. The Efficient Engineer, I get a lot of stuff from that for my classroom. Smarter Every Day, of course, you've probably seen that one. Of course, Vsauce. 60 Symbols is really good, all kinds of subjects. The old classic Flipping Physics is, I like it. I think he's funny, but if you're just trying to get into one subject and watch some example problems, that's good. Physics Girl, Diane has got 2 million followers, so she must be doing something right. She's devoted. She's very bright and devoted her life to this, so she's really good at giving demonstrations and stuff. And I've shown her stuff in class. Veritasium, I show that in class. He's great. Derek's great. Minute Physics, of course. Walter Lewin, that's the guy that started it all as far as videos for classes, physics classes. He started the whole thing with any kind of class, basically, by the way, from MIT. And he still gets on. He has his own YouTube channel. He still gets on there, and he'll talk at his kitchen table. And the guy's, brilliant. So Professor Dave, he's good at explaining some things. This is Dr. Thurston, and Dr. Thurston's actually a member of the Facebook group. He's a friend of mine. He teaches astronomy and physics at O-Trip, and he's probably one of the best physics professors in Oklahoma. So he started this last year. His does pretty better job than me, but this is his physics, and he goes through kinematics and all kinds of stuff in his own way. Doc physics, I've been following doc physics for years, and I get a lot of good. If I'm trying to figure something out, a lot of times I'll go to doc physics first because he's a gifted explainer. Hyperphysics is good reference, and then of course, and then Nick sent me this one, kinematics. It's basically it's Wisconsin, but they do a really good job breaking down all kinds of physics. So this would be good for you in college too. They break it down into all the different topics and then gives you sample problems. Then there's mine. I'm still working on mine, of course. And then the last one, guide 5, is books. Good summer reads, but books that I've read and I liked about, not necessarily always physics. Sometimes it's got just basic science. If there's a history and a science aspect to it, then that's the book I want. So Alchemy of Air is one of the better books. Probably one of the top 10 books I've ever read, I think. It's an excellent book, good summer read, not too difficult. Invention of Air is great too. Stephen Johnson's a gifted writer. Quantum 10, if you're interested in quantum mechanics and you want to kind of understand the origins of it. Not really a summer read, but one to read about 5 or 6 pages a day. Passionate Minds, that's of Emily de Chatelier and Voltaire. We saw a little bit of other than the movie, but this is a whole book about him. It's really interesting. What France in the 1740s and science, of course, Contact. I mean, hopefully you've seen the movie, but that is an amazing book as well. Black Holes, this is Kip Thorne, Black Holes and Time Warps. If you're interested in I doubt you guys are going to like this one though, but this is more for some of my friends that are on the Facebook group. John Gribben, it's a pretty thick, intense book, but it's a really good history book. Okay, so those are all the ones. I see Taylor Hale like that. He used to be a teacher at Norman High. Those are all the ones that I've had time today to stick up there, but I'll put more up there as the summer goes on, and hopefully I'll keep this thing going in the fall. Okay, still no sign of Zach, so let's keep going. I'm going to add one tomorrow, another guide number 6, and that's going to be history. I have a timeline that starts in 1495 with Da Vinci and goes all the way to 2100. And this year, there's nobody in here that was with me 2 years ago. But we used to hit history like once a week, and I just had to totally ignore history, which killed me this year. So I'm going to at least put it in my Facebook group, and so we have it as reference. Like today, we were talking about Alan Turing with some friends, and I wanted to be able to reference that real quick, but I don't have it on hand, so I want to get that so it's more on hand. Okay, now back to the show here. Okay, stop that sharing, and let's go back to the other show. All right, so now let's get back to this standard model. Learn some physics tonight. So this was a slide. Brandon wasn't here, but the rest of you were. This was one of the slides from yesterday where we talked about there more happened in the universe in the first 1 second than has happened since. Certainly as far as fundamental forces go. They all, by the time 10 to the, negative 20th seconds went by, already all the forces were broken up into the 4 fundamental forces. So what the Large Hadron Collider tries to do, essentially, in Switzerland, is an underground in Switzerland, is it tries to go back to the Big Bang. It tries to take us back to when all the forces were one. And that's basically what they're studying. They're studying the beginning of time, because that is when time started, at least for our universe. I don't have the chat open. Let me open that up. All right. So if you have something you want to ask, or if you want to just jump in, go ahead. Feel free to jump in. Because I say some fantastical things, and people say, Askey, you're crazy. But I'm giving you what's out there, folks. So we ended up last night talking about what Lisa Randall proposes. It's not just her, a lot of string theorists, Brian Greene and those, about the idea that there's two kinds of strings. One's open and one's closed. And we said that open strings would be like the electroweak forces. So electromagnetism and then weak nuclear and then strong nuclear, those are all open strings, meaning that they're attached to the membrane of our universe. But then there are closed strings, and gravitons are closed, the theory is. And so therefore gravitons can go in between universes. Okay, so it looks like our guest has arrived. We'll come back to the brain theory first. First, we're going to talk to Zach here. Now, hi Zach, how you doing?
I'm doing well. You hear me?
I can hear you. Can you guys give a thumbs up if you can hear Zach? All right, good. But what I want to do, hold on a minute. I want to get it so that you are still kind of learning all this stuff, but I want to get it so you are the main guy more. All right, let's do no, I don't want to break out rooms. Well, all right.
Your guess is as good as mine. I don't
know. Hold on. Let me stop sharing. That'll help. There you go. Okay. Last time I did an interview and I didn't stop sharing. And then when the YouTube came out, nobody could see who I was talking to. Oh, here we go. Okay. Multiple participants can share simultaneously. All right. So then let me see if I can blow you up. Pin spotlight for everyone. How about that? There you go. All right. Now you're the spotlight, Zach. All right. So what got me interested was your post on Facebook. And I showed them the post last night, or maybe it was last week, but where you had said, you had your struggles in class at your first year of college.
Yeah.
But then the thing is, you kept at it, and then you just finished taking the big test. So I guess first, I don't want to take too much of your time, but the first question is like, what was sort of your journey from when you left me back at 8-9 years ago to where you are now? Just a brief, like the highlights.
So I left, and then I left Norman High, and then I started at OU that next fall. And I'd kind of known the entire time I wanted to go into architecture or some kind of structural engineering kind of thing. I thought that stuff was all pretty cool looking. And so I chose civil. My dad talked me into civil engineering because I can still do that kind of work, but it's such a broad field and such good like job security usually. So like he convinced me that it's a good route to go because there's always work in engineering, construction, all that kind of stuff.
Mm-hmm.
And
that's assuming that the Congress passes an infrastructure bill.
We'll see. It's always infrastructure week. That's our joke. But
all right. Okay, sorry to interrupt.
But yeah, and so after that, I started my freshman year, and I think it was a big mix of just I feel like I coasted a lot through high school. Things just kind of came kind of easy, and then once you get into college, it really is more of a real world kind of thing, and the exams are harder, the schoolwork is harder, they expect more out of you, and I just didn't adjust well, I guess. And I was also living in the dorm, so I had a lot of freedom. I could stay up as much as I want. I could, no one's forcing me to go to class. So there was a lot of mishaps on my own end, just of being an irresponsible student, pretty much. And I think it was sometime my sophomore year, I started realizing I was getting to a point of no return where I need to turn things around. And that's whenever I started reaching out for help from all sorts of places, and people got me back on track. And
ask you a question. Let me ask you a question. So you said you reached out for help. What were some of the places you reached out for help on?
So one's kind of an unusual one. I joined a fraternity during my sophomore year. Fraternities are fun and stuff like that, but they also, they try and keep their own reputation within the college. And so, they require people that join, you have to go to so many study hours, you have to join so many things. And so that was kind of one, they would help force me into getting my grades up, because every fraternity has like their own cumulative GPA. They're not going to keep me if I don't do well and stuff. Mm-hmm. So there's that. I reached out to a lot of friends as well. That I just joined a bunch of study groups. I went to a lot more office hours. That's definitely for sure.
Yeah, good.
Office hours are your friends in college. That is definitely a fact.
Yeah. Okay, so then then you got back on track with college and civil. Was it? You were still civil engineering though when you were a sophomore?
Yeah, I thought about it. I looked into other kind of classes at some points, but all in all, I never officially dropped civil engineering.
Mm-hmm. Okay, so you got a degree. Did you get a degree in civil and then went on after that, or?
Yeah, so I got my bachelor's in civil engineering. Took me 5 years, and I graduated with that in the summer of 2018. Mm-hmm. And I guess one thing I forgot to mention that I also got help from, which is I had to do a lot of work on my own of just really studying to get my GPA up some more, but I eventually got hired on by the Oklahoma Department of Transportation, who I still work for now. Mm-hmm. They have like a program where they hire undergrads, and I worked like in an office right on campus pretty much, and I did a bunch of drafting and blueprint drawing, stuff like that. I didn't do any actual real engineering. We had another engineer, and he would just give us what he wanted, and we would pretty much draw up whatever he wanted for whatever plans that were going to be made.
That's what my son, my son Jacob's a biological engineer in Austin, and he's been there for about a year now. And basically what he still does is a lot of AutoCAD. That's how a lot of, and I think AutoCAD is extremely important if they kids can take that in a more Norman or something. But he said that, no, it's not really that important because they'll teach you what you got to know. But yeah, so you do spend a lot of time early on in engineering, civil or biological in his case, doing a lot of drafting.
Yeah, it's very helpful. You learn all about, once you get into actual engineering, you have to know how to read plans before you can make plans, and you can learn how to read plans whenever you're helping draft these up and stuff. Mm-hmm. So I got that, and that was a big help for me because, like I said, I was working with the DOT already. I had an office right there on campus. I didn't have to worry about rent or borrowing money from my parents for rent or food or anything like that. I could just work, and it gave me a lot more of a sense of ease during my last few years at OU, which helped me out greatly with studying, especially at that time. That's when you start getting into your core classes. Your freshman and sophomore year are more, just general maths and other prereq stuff.
Yeah. Okay, so you got your degree, and then you've been working with Department of Transportation, Oklahoma, ever since. But what is this test? What is this big test you had to pass?
So to start with that, I'll talk about the FE exam, because there's in engineering, you graduate, and then you can take the FE exam before you graduate too. But basically what that means is that it's basically like a certified document that shows that you still know what you were taught outside of college. And I think I have some heads. No, that's not it. But that certifies me as a engineering intern. And then once I get that, then I can start working towards my PE exam. And the way I always describe it is like the PE exam is kind of like how lawyers will take a bar exam. Engineers will take a PE exam, and not every engineer needs it. My fiance Jordan, she studied chemical engineering, and there's a lot of people that do mechanical engineering, and they don't really need a PE because a lot of times they just do. They make things more efficient, but they don't actually do a whole lot of new designs. They do a lot of analysis kind of stuff. But with civil engineering, like everything is always a brand new design, pretty much. So it's pretty much to have a PE, because then you get
that test isn't cheap. That test is expensive.
I think just signing up for the exam itself was a little over $500. So that's not too bad. But then you also have, like, it's all an open notes kind of exam. So that's where they really get you in the exam. Like, you can know all of your equations and stuff like that. But there's a lot of questions where they ask you, like, I have a bunch of books actually with me. Like, there's like, this is just one book, and it's this thick, and you'll have to like look up like a single number out of that one table.
Right.
It's all.
So you got to know what. So they're basically memorizing ain't gonna do it for you. You got to know your stuff.
Yeah, it's nice that you can take in anything you want pretty much, but they take it that the people that write the exam take advantage of that as well, and they can ask you anything out of those books.
So now that you have
all the books themselves, like I said, the exam isn't too expensive, but all the books, if I were to buy them all brand new off of Amazon, it's almost $4,000 for all those books combined.
Wow.
Luckily, an engineer in my division let me borrow his.
So you still need books. It's not all on the web.
Yeah.
So now that you have that exam behind you, now what's next for you? Does that mean a raise, or does that mean different position, or?
Yeah. So the way the PE works is that you have to pass. There's like 3 main requirements. You have to pass the exam. You have to pass an ethics exam, which is basically saying that I will, if I'm going to approve off any designs, I have looked through them. They are all up to code. Basically saying that I am responsible,
right, if anything collapses.
And it's like, and I was just negligent, then it's saying that I, all that kind of stuff. I'm not going to sign off on negligent plans. Right. So those are 2 things. And I also have to have 4 years of experience underneath another PE. So I'm about 3 years out of college now. I can get my PE license next year in about September, I think.
That's great. That's great.
And yeah, like you said, you get a different position. You get a raise. That's the good part. I work for the DOT, so it's all state. But if I worked for a consultant, all my professors always told me that once you get your PE, you're pretty much guaranteed like a $10,000 to $15,000 raise sometimes.
Nice.
So
nice.
It all varies.
Well, it's good to get all that experience. Now, I have one last question, and then we'll let you go. Why are you responsible for the fiasco from Paola to Paul's Valley?
Yep.
It is 20 miles of construction. I just sat through that going down to Austin.
I have seen a bunch of things that the DOT posts on Facebook about work on 35, so I think I know what you're talking about. But I currently live in Tulsa. My position right now is I'm a project manager in the construction field right now, so I help oversee projects. So if you want to complain about stuff in Tulsa, you can talk to me. But down towards Paul's Valley is not my jurisdiction.
I was barking up the wrong tree. Daggone it.
Okay. Yeah, I am actually going to be moving back to Oklahoma City pretty soon into their so all the highway geometry and all that kind of everything. I'm going to be in their traffic division. So who knows, you might be able to complain to me soon, but that right there is not me.
I'll put you on speed dial. So when you get back here. All right, Zach. Anybody, we're going a little long, taking up his time here, but anybody got a question? Anybody in the studio audience? So I got 4 students that are here. A lot of students don't
Yeah, I don't
here
mind staying a
live.
little
They
longer
just
if
want,
I need to answer any questions.
yeah. If anybody has something, otherwise we'll go on. We'll go back to the Big Bang and the brain theory. All right, they're all being quiet. Well, okay, Zach, you can hang around all you want, but we're going to go back to what we were doing, and thank you for coming by.
Yeah, I think
Appreciate
I'll
it.
go ahead and get off. I'm probably gonna watch the rest of this softball game that just started.
Oh, that's right. Okay, thank you. Thanks for reminding me. I'm going to watch that myself. Okay, we'll see you later then. Thank you, Zach.
All right. Thank you,
Bye
Askey. It
bye.
was great seeing you again.
Yeah, good to see you. Okay, that was good. And Zach was a good student in class. He, you know, he wasn't, I don't know if he's a Hall of Famer. But he worked hard and, um, but yeah, he had tendency to sometimes drift off, but I'm impressed. That PE is a big exam and tough exam. Okay, so back to our brain theory now. So yesterday we were saying that gravitons, since they're closed strings, they can go in between universes. If there's and the theory lately is that there are billions of parallel universes. We're only one, and there's been billions of big bangs. And so one of the theories then on brain theory is that if we have a brain, two brains, say this is universe one and this is universe two, and they overlap, eventually one thing that could happen is they could pinch off into another universe here, or one could have a loop, and then this right here would be the Big Bang. Okay, would be now a new universe is born, new brain is born. Okay, so at least you are now cued into some of the latest. I mean, you get into physicists start poo-pooing religion and saying, "How could you have this crazy story?" Well, they have. I mean, physics does have some numerical evidence of things, but it starts to get the point of fantasy in science as well when you go back to origin. You know, the story of the origin. Okay, we're not going to get into that. But what this is kind of dancing around is this standard model, and this is a very simplified view of the standard model, showing the three basic. Well, throw in the Higgs, so I guess the Higgs boson kind of it's this part. It's the Higgs field really that gives everything mass, but everything has to have a particle, and the Higgs particle is what they found about 5 years ago, named after Peter Higgs. But in the standard model, it's basically all matter that we know of in our universe is separated into either quarks, and quarks are subnuclear. They are between protons and neutrons. They make up protons and neutrons. And then there is leptons, and leptons, the most familiar one to you is the electron. There's also muons and there's neutrinos. These are all on the order of leptons, much less massive than quarks. And then there are the forces. There's the four fundamental forces and the four fundamental force carriers. Photons, of course, we all know about. Bosons, there's Z bosons and then W bosons. And then there's these gluons, which gluons is what holds a nucleus together. Okay, so here's a little more detailed view of that, and I'll give you the reference to this. The reference to this is something called Quantum Diaries, and I would suggest that's a good look for you. And I'll put the link in the comments. So here is the same thing we just showed you, but a little more detail, more like a sort of like a periodic table or something, where it's giving the spins, it's giving the charge. It turns out when I was in high school and college, I learned that electrons are negative and protons are positive, and I thought, okay, that's pretty simple. Well, it turns out that's true, except that that's not the fundamental charge. At least as far as we know, the fundamental charges are 1/3. So like a down quark is negative 1/3 in charge, an up quark is positive 2/3. I don't know if you all talked about this in your, like, give me a thumbs up if you talked about quarks fractional charge in chemistry. I think the only time you would have talked about that is AP chemistry. And even then, Powell might have spent 15 minutes on it. But it is interesting to think that, like, for instance, a proton is 2 up quarks and a down quark. Well, the up quark has a 2/3 charge. So if I have 2/3 charge, it's 4/3, and a down quark has negative 1/3 charge. So that makes it a positive 1. You see what I'm saying? Neutrons are 2 downs and an up. So neutrons have a up quark and then 2 down quarks, which then ends up being 2/3 minus 1/3 minus 1/3, or 0 charge. So neutrons are neutral. But it turns out that charge then is actually a third charge, a 1/3. Now, maybe we'll find something that makes up gluons one day. I mean, makes up quarks one day, and we'll think, okay, it's actually 1/9 or something. But that's probably 50, 60 years from now. Okay. So I wanted to, that's a standard model. And then where we're getting that standard model was a lot of work from CERN, which is in Europe. And it started in the 1950s. CERN did, not the LHC, but CERN itself. There's been other particle colliders besides the LHC. And that's where they first started to figure out the standard, more about the standard model. Otherwise, before that, it was mostly theorized. The first particle collider was about the size, if you can see my hand, about that big, in a small little container. So I want to show you now this 6-minute video, and then we'll leave it alone. What's next? Okay, then we'll leave that alone. We'll get back. Oh, we'll get into tides a little bit. Get back to gravity, back to mechanics. But every year, it's not, I'm not going off on a tangent here, because this is the one thing we had one of the things we had to drop this year was any talk of standard model or of Large Hadron Collider. So I'm going to go ahead and pause the recording and resume. Okay, back to recording again. And for those of you that are watching this, what we just did was we spent about 6 or 7 minutes watching the video of the Large Hadron Collider. It's an animation, and you'll find it in the comments, but you need to watch that to kind of get a feel. So, because I'll refer to it off and on. Okay, so now I'm going to get into tides in the last 8 minutes here. All right, so this is my slideshow. I'll just blow it up. So, tides, each day we have 2 tides, and that never made sense to me. I mean, I understood, and Galileo tried to figure out tides too. He was wrong. He thought it was kind of like having water in a barrel, and then if you spin the barrel, the water all kind of goes to the outside. That wasn't it, because the earth spinning. They didn't realize, I mean, that was still advanced for the day. Remember, no one thought the earth even spun back then. And that was also that while I was watching that Large Hadron Collider animation, I'm thinking, we have people on this earth that are that smart, that can build these things, understand these things. Yet on the same earth, we have people who are convinced the earth is flat. I don't know if we've had this big a chasm in intelligence ever in the history of mankind, from the dumbest poor souls to the smartest. The rest of us are all somewhere in between. Anyway, so this is a graph of tides, high tide, low tide, throughout a 12 a.m. Throughout a 2-day period. And we do all these are tidal predictions, and you can do these for the whole year. You can do it by the month, for the whole year. And this is basically, I mean, NOAA does these, and they're basically using Newtonian physics, the kind of physics, one of the main equations they're using is universal law of gravitation, all based on Newton's laws. So you can look at a table and know what the tide will be And there's other things involved as well, but you can know pretty much within inches of what the tide will be a month from now or even a year from now. It's crazy. Newtonian physics works pretty well. But the question is, why do we have tides? Anybody want to hazard a guess? Obviously, the moon's involved, right? But it's not quite as simple as it seems. It makes sense to say that, okay, let me do this. Let's draw a quick Earth-Moon system. So it makes sense. I have the Earth. Terrible drawer when I have to draw. Okay, hold on a minute. Let's do it this way. So I have the Earth. Okay, and the moon. Say the moon is here. Say the moon is here. All right. Earth, moon. That's pretty close. Of course, the moon's a lot further away than that. But then it makes sense that you would have the ocean would be pulled, because water is pulled towards the moon by Newton's law of universal gravitation. But it doesn't line up. It doesn't line, like the bulge is right here, say, but it does not line up perfectly with the moon. There is some friction. And so there's a lag. All right. There's a lag between where you think it would be and where it actually is, but they take all that into account. Now that makes sense because I get it, gravity. But then why is there a neap? They call it a neap tide. And some of you may have lived on the coast. You know what a neap tide is. A neap tide is the other one, the other side of the earth. Why would that? I understand why this side would have high tide because the moon's pulling up the water. But why is it high tide on the other side of the earth? And this is what Galileo tried. Galileo understood he didn't understand Newton's law of gravitation. They hadn't even invented yet, but he did understand the idea of gravity and saw that, well, probably the water's being pulled to the moon. But what he didn't, that's when he messed up, because he said the other side, that neap tide, is because of this kind of water sloshing in a barrel. And that's not it. Anybody know why there is this? This is called the neap. I think it's NEAP. Why is there a neap tide? You have to turn on actually, hold on a minute. I can get the chat back up. Oh, Jacob's saying the moon and the earth pulling. Yeah. So moon. Well, okay. So he's answering my question. He's saying that the moon on the neap side, in this case, okay. So here the ocean's being pulled towards the moon. Here, the ocean is being left behind. It's not just the ocean; it's lakes. Oceans do it. Oceans are more pronounced because there's a lot more water. But here the ocean's being left behind and the earth is being pulled. Here's my little drawing on that. The earth is being pulled towards the moon more than the ocean is, because the earth is 5 times more dense. Typical rock is 5 times more dense than water. So the earth is basically the water here on this side is being left behind, and that makes the tide. Then the tide's not as great, but the neap tide's never as great as this tide on the moon side. And so it's kind of weird to think, okay, so one's a case for the water being pulled up to the moon, one's a case where the water's kind of being left behind, and the earth is being pulled to the moon more than the water because it's more dense. Okay. Does gravity cause tides? The same thing I just showed you there. Okay, and that's what we just got finished talking about. Far side, and then the high side. Sublunar. Oh, this is called antipodal versus sublunar. And then we have this thing called tidal friction, what I was saying. And what happens is the tidal friction gradually slows down the Earth's rotation. So the Earth is slowing. I think it's like a millisecond a year or something. It's not something that's going to really affect you, but we're doing that because of tidal friction. The moon is tidally locked. And now I'm going to show you, we got 1 minute to go. I'll make this one of the first things I'll show you next time. The moon, we always see, there's the dark side of the moon, right? because the moon itself has become tidally locked with the Earth, just like Mercury is tidally locked with the sun. Anything that orbits, they both eventually, the Earth and the moon will both become locked in place. It'll take us a lot longer. The moon used to orbit faster. Tidal friction has caused it to lock into synchronous rotation. So it rotates at the same rate we do. Well, so that we only see one side of it. We never see the other side. So tidal friction is also what's causing the moon to move further away. It's all about energy and rotational energy. It causes the Earth to heat up. Tidal friction is what causes, I believe it's Europa or Io, I think, of Jupiter. That whole moon continues to be tidally affected, and Jupiter squeezes it and lets it go and squeezes it, and all this internal friction builds up. And so there's all these volcanoes on that moon because of tides. So there's the bulge is always slightly ahead of the Earth moon line. I talked about that. This talks more about tides. There's a good website there. We talked about that. The phases of the moon is also there's also the sun plays a role as well. Sun's much more massive, but as we saw, it's an inverse square law. It's much further away, but spring tides are the highest. Neap tide. Neap tide's what I was thinking when I heard your word neap. I mean, the neap tide is when the sun doesn't line up with the moon. I had that wrong. But spring tide's when the moon and the sun all line up. So the sun, people will say, well, it's the sun. No, sun plays a slight role, but mostly it's the moon. Okay. And then next time, we're out of time now, but next time I'll talk a little bit about, for a few minutes, about how that's causing the moon, how that's causing the Earth to slow down, and why is that? Because that gets into energy, rotational versus friction. There's all this friction that occurs between the water and the Earth itself rises and falls. There's land tides that follow the moon as well. Okay, so next time, I promise you, we're going to get to pulleys. I keep saying we're going to get to pulleys. And then that'll lead us to more machines and more work and energy. We are going to hit all that. And then we got to still get into torque. So that's my problem, is that everything's interesting in physics to me, and I end up getting into standard model, which I think is the only time we're going to get it, maybe. So I'm trying to make it a variety show. So I'm trying to keep it. I don't want to make it a class. I want to make it something that's always different. You never quite know what's going to happen. And I'm not trying to shock people with stuff, but I want to be able to keep your interest peaked. So feel free to in the chat, or not in the chat really, but in the comments, or DM me suggestions, or maybe what would help the sound, or keep you more interested, things like that, because this is a whole big experiment. That's what we're doing here. Whether I'm going to do it in fall or not depends on how this goes. Okay, so you guys are I'll stop the recording, and